Number 41 we're going to do over here on the left, and we have a base to a power x minus 2 equaling a base to a power x minus 1. Are those bases, 3 and 5, in the same power family? If the left was 3 to the x minus 2 and the right was 9 to the x minus 1, you might approach this problem a different way, right? It would be a little bit easier because we would then rewrite 9 as 3 squared to the x minus 1, and then you could just go from there. Everybody know where I'm going with that? It's not this type of problem. If it was like number 39, I would do that way. Number 40, I would do that way. But 41 and 42, you're going to begin by logging both sides. So take the log of both sides. If the bases aren't in the same power family, you're not going to do the thing where you try to get them to match. That's number 39 and 40, which nobody asked for. So the reason we do this is so that these exponents can release to the front. Okay? This x minus 1 can be brought to the front. That's the purpose of a log, to get the variable out of the exponent. All right? So the x minus 2 will swing out in front of log 3, and the x minus 1 will come out to the front of log 5. All right? At this point in these problems, I have you keep log involved. Some teachers will say, go ahead and find the log of 3. It's some decimal. 1 point, no. Yeah, no. What would the log of 3 be? Point something, all right? And you could find the log of 5, which would be point something. I'm not sure what it is. But I propose that we keep the log of 3 and distribute it. Okay, so that would be x times the log of 3 minus 2 times the log of 3 equals x times the log of 5 minus 1 times the log of 5. And as you sit there and look at that, look from left to right and tell me which term has an x in it. A, B, C, or D? Which two terms have an x in them? A and C. So we got to group those on the left. B and D don't have an x. We're going to move those to the right. Separate your haves from the have-nots. Which terms have an x? Which terms don't have an x? So x log 3 will stay on the left, joined by minus x log 5, because we're subtracting it over to the left. Negative 1 log 5, can just be negative log 5, is going to be joined by, what would that be if I move it to the right? Plus 2 log 3. The reason that I wanted to do that, and we had a warm-up the other day where we practiced factoring. Do these two terms now have a common factor? Yes. So you bring the x out in front of log 3 minus log 5. And that equals all this business. Log 5 negative plus 2 log 3. We're almost there. Our whole goal was to solve for x. Find x. Where's x? There it is, all by itself. If I divide by log 3 minus log 5. So x will equal this stuff divided by this stuff minus log 5. So that's what I'm about to type in my calculator, and if you're watching the video, it's going to jump straight there. But before we do that, we found an error. That should be a log 3. Thank you. So here it is, and make sure you notice the opening and the closing of the parentheses. The entire denominator is held in parentheses. But when you hit log, it opens up a parentheses automatically. You got to close it before you enter the minus log 5. Okay, so just be careful with your parentheses. When you hit enter, you should have the solution, negative 1.151. That's what we think x is. So when we go back to the problem, we now think that x is negative 1.151. So how could I check it? Right. Take 3 to the negative 1.151 minus 2, and then take 5 to the negative 1.151 minus 1, and make sure they're similar in answers. Okay? That's how you can check your work. Stay live. Here we go. 3 to the what? Minus 2? Seriously? Okay. Hit enter. And then 5 to the minus 1? Good. They're pretty close, right? I mean, they're identical up until the, I don't know, what, sixth decimal place? So that's a very good answer. They're not exact because we rounded negative 1.151. All right? So we have a valid solution.